Alright, so welcome, and right now we're going to do a physics problem for kinematics. And what we have here is we have a hunter who's right here, and he's trying to shoot a monkey up in a tree. There's this guy right over here. And what he's doing is he's pointing his gun at the monkey, straight at the monkey, and then firing. The monkey's pretty smart. And when he sees the hunter firing, he immediately lets go and starts falling out of the tree. So we want to figure out is if this hunter is going to hit the monkey. So the tree is a distance d away from the hunter, and it's h meters tall. So let's go on and start the problem. So there's two things that are really going on in this problem here. We have a bullet that's heading up with initial velocity v0 up towards the monkey. Then we have the monkey who's falling straight down with no initial velocity. So let's start looking at the bullet. The first thing we have to figure out is how long it's going to take the bullet to get to the tree. So we can start with asking ourselves what we know. So the initial velocity is going to be equal to the x component of the total initial velocity. Then we know that it's going to travel a total distance of d meters to get to the tree. It's going to, then there's no acceleration on it, so acceleration is 0 meters per second. And then we're trying to find what t is equal to. So that's our unknown. So for this, we're going to use the equation delta x equals the initial velocity times time plus 1/2 the acceleration times time squared. So in this case, we know that the acceleration is 0, so we can just take this term straight out. We know that delta x is d, so d equals v0 x times time. That means the time it takes for the bullet to get to the tree is equal to v0 x divided by d. So that's going to be our time for the entire problem. Okay, so our next set of movement is the monkey falling straight down. So let's start with what we know. So what is our v0? Well, in this case, at the very beginning, the monkey is perfectly stopped, so he's going to be moving at 0 meters per second. Then we don't know how far he's going to fall, but that's what we're trying to find out. We know that if at the time that I figure out here, v0 x divided by d, if both the bullet and the monkey are in the same vertical position, then they're going to hit each other. So we're trying to figure out where he ends up. Then we know what the time is. It's going to be v0 x divided by d. And we need one more thing, which is the acceleration. So the acceleration is going to be due to gravity, which is going to be negative g meters per second squared. So this time we're going to use the same equation we used last time, except this is going to be in the y direction. So delta y is going to be equal to v0 y times d plus 1/2 at squared. So this time the initial velocity is 0, so we can just take this term out. So we have y final minus y initial is equal to negative 1/2 g t squared. So in this case, we want to solve for y final. So we're going to take y final is equal to y initial, which, because the monkey starts in the top of the tree, is going to be h, the height of the tree. And this is going to be minus 1/2 g, and then t squared. So that's v0 x divided by d squared. So this is the vertical position of our monkey. Now we have to figure out what the vertical position of the bullet is. So we're going to do exactly the same thing that we did for the monkey. We want to figure out what y final is. That's our unknown. We know that the initial y is going to be 0, because it starts on the ground. Then our acceleration is once again negative g meters per second squared. The t stays the same, because that's the time we're working at. V naught x divided by d. And then the difference this time is that v naught y is equal to some v naught, because the bullet is fired out the gun and is moving initially. So when we look at it now, we have y final minus y initial is equal to v naught y times t plus 1/2 at squared. So we can cross out the y initial, because that's going to be 0. We have y final equals v naught y times v naught times v, that's the right value, d divided by v naught x, and then once again minus 1/2 g d divided by v naught x squared. So if we look at this is the position of the bullet, and if we look at the y of the monkey, that was equal to h minus 1/2 g d by v naught x squared. So you can see that the second terms here, one from acceleration, are both the same. So we have to figure out if there's some way where we can relate this term here to h. And here we're going to use a little bit of trick. So if we look at the initial problem, we can see that we have a sort of triangle here. So this is the h of the tree and the d from the distance. So there's going to be some angle, let's call it theta, between the two of them. Then we also have to look. This means that the tangent of theta is going to be equal to the opposite over the adjacent, so that's h over d. And then we can also look at the velocity vector. So v naught is going to go like this, and then there's going to be an x and a y component, so v naught x and v naught y. So as you can see, this also forms a triangle, and because the hunter is pointing his gun straight at the monkey in the tree, this is going to have the same angle theta as did the original triangle. So that means that we can also say that tangent of theta is going to be equal to v naught y over v naught x. So if we go back and look at the equation for the y location of the bullet, that was equal to v naught y times d over v naught x minus 1/2 g d over v naught x squared. So rewriting this just a little bit, we can make this v naught y over v naught x times d. Then we'll keep the second term the same, 1/2 g d over v naught x squared. So as we said before, tangent theta is going to be equal to v naught y over v naught x, and it's also equal to h over d. So that means we can substitute h over d into here. So h over d times d, we can have the d's cancel. And minus 1/2 g d b naught x, that is still squared. This means that the final equation for the y location of the bullet is equal to, not b naught x anymore, rather it's going to be h minus 1/2 g b naught, or d over b naught x squared. And remember, this is exactly the same as our equation for the y position of the monkey. It started at initial height h and fell at the same rate. So because the y positions are the same, when t is equal to the time that the bullet will reach the tree, we know that by aiming at the monkey right as he falls, the hunter will hit the monkey. So in this case, the monkey gets hit by the bullet. So, I'm glad you listened, and this is one of the classic problems in kinematics. Thank you, and I hope it helped. Stop.